So some of this video is you can probably skip if you have done logs in maths already. Then some of this will be just, you won't need. This will be a lot more simple than the stuff you know already. But if you don't do maths or you haven't done the use of logs in maths, then you might want to watch it. Right, so the pH scale is a measure of hydrogen ion concentration. Okay, so I'm going to put square brackets hydrogen ion concentration, and that varies enormously. It can be as high as 1 mole per decimeter cubed in some aqueous solutions. So if you have a bottle of hydrochloric acid, 1.0 mole per decimeter cubed, and it can range all the way down, right? So I'll show you at pH 7, the concentration is 1.0 times 10 to the minus 7 moles per decimeter cubed. That might give you some clue what's going on here. At pH 14, which is a very alkaline solution, the concentration of hydrogen ions, there's still some there, but it's very, very low. It's 1.0, right, times 10 to the minus 14 moles per decimeter cubed. So it varies enormously. So, and we've seen before, if you've got a large range of numbers and you want to squash them into a more manageable range, then you can use this mathematical function called a log. Okay, and we use, strictly speaking, it should be log to the base 10. That's one we're using here, and we'll explain what that means in a minute. You probably you can probably guess, you can see what's going on, 14 there, 14 there, so you can probably guess what's going on already, but let's just do it a little bit more, explain in a bit more depth. Right, so what you want is your calculator. Okay, so I've got a picture of my calculator there. That's gone, sorry. There's my calculator. You've probably got them similar, and the buttons that we want are, I'll make that a bit bigger. If you want to look at these buttons, the ones you want is this one here, that one there, the log thing. Now, really, that should have log. It should be written log to the base 10, but most people just leave it as log. It's equivalent to log. Right. So if you put some numbers in your calculator and you do log, let's say do log 1, do log of 10, log of 100, and log of 1,000. Right, that will give you an answer of 0. That will give you an answer of 1. That will give you an answer of 2. That will give you an answer of 3. And you can probably guess without doing it, if you had 10,000, log of 10,000, that's going to give you a log. The log of that will be 4. So you can begin to see what log to the base 10 is. Log to the base 10 is what number you have to raise 10 to get that answer. So for example, 10 squared is equal to 100, isn't it? Yeah. So that's why the log of 100 is 2. Okay, so that's easy for numbers which are factors of you're going to factors of 10. But let's think, what would happen if you had a log of 50? Now you can probably know that it's going to be bigger than 1, isn't it? But smaller than 2. If you put it in your calculator, you'll get that log 50 is actually equal to 1.69 something, I think. Log 2. Sorry. Log of 50, sorry, is 1.6989. Okay, carries on like that. Okay, so what does that mean is that if we do 10 to the power of 1.689, that is going to be equal to 2. So we know how to use the log button. let's use then, if we want to think that it's the opposite of log, which is sometimes called anti-log. If you want to do that, then you press the shift button and the log button. And if you look on the log, on the shift, if you do shift log, there's a little yellow 10 to the power of x up there. So if you do, like, let's just pick a number at random. What is 10 to the power of 2.50? Well, I know it's going to be, I can tell you what the answer is. It's going to be bigger than 100, isn't it? Because that's 10 to the power of 2, but it's going to be smaller than 1,000. So let's see what it is. So I do shift log 2.5. The answer is 316.2. Okay, so that's what logs are. Now, normally, because I said we are dealing with our pHs, which are these small numbers. Okay, so let's just, what would be, let's do here, log of, let's say log of 1, and let's do log of 0.1, log of 0.01, log of 0.001. Right, log of 1 is equal to 0 because 10 to the power of anything to the power of 0 is equal to 1. You might remember that. This one, if you do it on your calculator, that's going to be minus 1. So the answer there, the log of that is equal to minus 2. The log of that is minus 3, and so on. Thanks very much. Cheers. Cheers. Okay, so most of our numbers, H plus concentrations are less than 1 mole per decimeter cubed. So we need to think about that. Now, the formal definition of pH is this then. pH is equal to the minus log to the base 10, which you leave the 10 out, of the hydrogen ion concentration. And the hydrogen ion concentration has got to be measured in moles per decimeter cubed. And then it's very useful to have the converse of that, is we can have hydrogen ion concentration is equal to the power of 10 to the minus pH. And that's very useful to remember that. So whenever you want to convert these. So let's say we have let's say we've got a solution of ethanoic acid. Doesn't matter what it is, it's a little question here, okay? So you've got a solution of ethanoic acid. And say that's pH 2.6. 2.6, we normally give pHs to 2 decimal points, by the way, get into the habit of doing that. Well, what's the hydrogen ion concentration going to be for that? The hydrogen ion concentration in that solution is going to be 10 to the power of minus 2.60, which is equal to, so you do shift log minus 2.6 is 2.51 times 10 to the minus 3 moles per decimeter cubed. So the hydrogen ion concentration is pretty small. Let's do the, now say we've got a solution of sodium carbonate. And we find the pH of that is equal to 11.20, okay? So what's the hydrogen ion concentration of that solution? It's going to be equal to 10 to the power of minus pH, and that is equal to, so you do shift log minus 11.2. That's 6.31 times 10 to the minus 12 moles per decimeter cubed, which is a tiny number, isn't it? And that's why we use logs, because the value of the hydrogen ion concentration in everyday solutions can vary so much. So it's much easier to write down 11.2 rather than writing down all these tiny these numbers here. Before we finish, let's just do the converse of that. Let's say, so we have we've got a solution of H plus ion concentration equal to 5.90 times 10 to the minus 7 mole per decimeter cubed. What's the pH of that? So pH, you just do minus log of that number on your calculator. So do that log. So you can put the minus in first if you like. 5.9 minus 7. Right, that's 6.229. We should always give it to 2 decimal places. So 6.23 is the pH. So you can see there at 25 degrees C, that solution would be ever so slightly acidic. Not much, but ever so slightly. Okay, so in the next video, we're going to talk about why the hydrogen ion concentration can vary in aqueous solution, see what's going on there.